Hello everyone. For this video, I want to review the KSAT math test admission year of 2024. KSAT stands for Korea Scholastic Aptitude Test. For the student or general person who want to admit university in Korea, usually are required to take this exam, which usually takes place on November. Okay, for this video, I want to review the problem number 22, which is a odd type paper, the required section. Okay, the point of this problem is a logic. You separate the you proceed case by case, following the logic, and produce your explanation step by step. And by doing so, you discard non-logical things, and you only choose the result which makes sense. Okay, so you have to determine whether it does make sense in terms of the condition of the problem of this one. Let me go directly dive into this problem. For the cubic polynomial, cubic function whose leading coefficient is 1, which is positive, the graph of this cubic function looks like this. Okay, or it depends on the situation. It can go like this without local max or minimum, local extreme value. For instance, if fx is x cubed and its derivative will be 3 times x squared, which is non-negative. By the way, this cubic function do have a negative derivative, so the second case is not the case, because for the second case, where there's no local extreme, the derivative is always non-negative. Okay, so we just choose this first case. There are local maximum and minimum. Let me erase this part. Okay, I'm gonna focus on the first case here. And then we do have a specific value of its derivative. For the negative derivative, that corresponds to this interval. For this interval, the derivative will be negative. This is an open interval here, not closed. And to make precise, this is a graph for cubic function whose leading coefficient is 1. So let's assume that we have x coordinate here, and then around here we have negative 1/4, and for the positive 1/4 its derivative is also negative here, and there's a 0 integer between negative quarter and positive quarter. On this problem I want to focus on the integer value for the x here, because the value of k takes only integer value. Okay. On this problem I will separate cases by cases. The case 1 is, what if f of 0 is non-zero. Okay, it could be positive here like this, it could be positive or negative. Let's say just f of 0 is positive. You can do the same thing for the negative value for the f of 0. By the way, here on this problem, the value k plus 1 and k minus 1 is ending point of the interval whose length is 2. Okay, those two ending points, we compute its value, and there does not exist the two ending points whose length of interval is 2 and their ending points are integers, such that their multiplication is negative. So simply take a look at for this case, which I have already drawn. The partner for this 0 could be 2 or negative 2. So in the case of 2, since f of 0 is positive, f of 2 is also positive. So it does not matter for the positive case, because in this case f of x is positive for positive x. Okay, but let's take a look at the value of f of negative 2. F of negative 2 can be either positive or also 0 here. The graph goes to takes negative value eventually as x goes to negative infinity here. It becomes negative here. So I have two cases. Either f of negative 2 takes a positive value, or f of negative 2 takes a 0 value here. Here f of negative 2, around here f of 0 here, f of 0. I roughly have drawn the graph. So in this case, f of negative 2 should be positive. Okay. Here there is an important observation. All the zeros should be integer. Why? Because if this zero, the only zero that this cubic graph has, if this zero is not integer, let's assume that this zero is not integer, and there should be a predecessor integer L and its successor integer L plus 1 here, and this integer is strictly between L and N plus 1. Okay, and the partner for L plus 1 is L minus 1 because the length of the interval is 2 here, and they take some different value, different signs. So if in this case f L minus 1 multiplied by f L plus 1 becomes negative because L plus 1 positive and f of L minus 1 will be negative value here. Okay, so all the zeros should be integer, like for the second case. So here let's simply assume that this only zero for the case 1, let's say, let me restore the graph here. It is negative 2. Let's say this is a negative 3. You can do the same thing for the negative 4. You can choose any integer value which is less than negative 2 here. The integer 0 here. Okay, and then there will be in case of negative 3, the partner for negative 2, which is negative 4 here, which is negative value. F of negative 4 is negative value, and f of negative 2 is positive. So f of negative 4 times f of negative 2 will be negative. So this is not the case. Okay, so if we change the integer 0 as another value, say for instance negative 5 here, and there will be negative 4 between negative 5 and negative 2, and there will be negative 6 on the left side of the graph. So if you multiply the value of f of negative 6 times f of negative 4 would be also negative, because f of negative 6 will be negative and f of negative 4 will be positive here. Okay, so what's the conclusion here? This case does not make sense. For the case where f of negative 2 is positive, or you can do the same thing for the negative f of negative 2. Okay, so this case covers, let me say, f of negative 2 is non-zero case. case 1-1 covers for the case non-zero f of 2, and then for the case 1-2 covers for the 0 f of negative 2. However, when f of negative 2 is 0 and f of 0 is positive, we have intermediate integer f of negative 1 and their partner, the partner negative 3. Here you see f of 3, negative 3 is negative value, whereas f of negative 1 takes positive value, so their multiplication will be negative. Okay, so for the case f of negative 2 equals 0, it also does not make sense. In conclusion, the non-zero f of 0 case, it does not make sense. Makes sense. That means f of 0 should be 0. That's our second conclusion here. The first conclusion is all zeros should be integer, and second conclusion is f of 0 should be 0. Okay, it makes our life easier. Let me clear this paper a little bit. So okay, what we have is the first all zeros of f of x should be integer, and the second is f passes through the origin. So the graph for y equals f of x will look like this. And then it passes through the origin here. This is 0. Just roughly, let's point the negative quarter and positive quarter here. It's just a rough case here because negative quarter, both negative quarter and positive quarter should have negative derivative, so they should be lied on this interval, open interval here. So what's next? Here, let me give you apology. The first conclusion may not be true. This is too strong. I will explain why this is not true on this time. Okay, it can mislead you. This is too strong sentence. This may not true because I can assume the two cases. The first case, we have the 0, the smallest 0 is a negative 1 here, and the biggest biggest 0 could not be, it does not necessarily integer. If this biggest 0 is between 0 and 1, let's see what happens here. Okay, for the here, because let me finish this line, because f of -1 0, and then f of 1 positive case here, and then this biggest 0 is not non-integer, it becomes non-integer, and still it's okay, because you can check for this, because for the partner for -1 is -3 or 1, but since as long as f of -1 is 0, f of -1 times f of 3, f of -1 times f of 1 is always 0, so their multiplication is not negative. Okay, this is 0, negative, 0, positive here. Okay, and also the partner for 0 will be 2 or -2, but since f of 0 is also 0, you can do the same thing for the f of -2 and f of 2. So it does not break this condition. And for the other values, other partners, for instance, for the partners of 1 is 3 or -1, their multiplication is non-negative here. So this case makes sense. So the sentence that all the zeros of f of x should be integer is not true. It's false. Let me apologize for this, but for the specific case, f of 0 should be 0. That's the only point that I can induce from the previous one. So I can divide two cases. The first case is where f of 1 is the negative. Then we have two cases that when we have a positive f of 1, or when we have 0 f of 1 here. So for the first case, 0 f of 1 here, and for the second case is positive f of 1 here. For the case of f of 1 is 0, here the value of -1, which is partner for this one, could be 0 or could be negative. I mean, f of -1 could be 0 or f of -1 could be negative, because if I have positive negative 1 here, f of negative, if f of negative 1 is positive, and then we have two cases. The first case is where we have the smallest 0 here as an integer. The second case is where we have the smallest 0 as a non-integer value here. Non-integer. For the first case, when the smallest 0 is integer, and then since f of negative 1 is positive here, so this integer value could be negative 2 or negative 3, as you like. If it is negative 2, then the partner for negative 1, which is negative 3, will have a negative value for f of negative 3 is negative. So f of negative 1 is positive. This does not make sense. And when the smaller integer 0 for this smallest 0, say this is negative 4, and then we have negative 3 as an intermediate value, which makes f of negative 3 is positive, and each partner value, each partner f of negative 5, which is negative, so their multiplication will be negative. So this is not the case. So the for the positive f of negative 1, the smallest 0 cannot be integer. And then for the non-integer smallest value, there will be an integer, say ln l plus 1, which contains this non-integer value strictly inside this interval ln n plus 1. And for the partner for l plus 1, the partner integer will be f of l minus 1. This value will be negative, whereas the value of f of l plus 1 will be positive. So this is also not the case. So conclusion for this is that f of negative 1 cannot be positive here. So negative 1 cannot be here, but it could be the 0 or it could be negative. Okay. And for the case of positive f of 1, its partner value is which is negative 1 here. So it could the value of f of negative 1 could be positive, or it could be 0. So 0 value is always the safe choice, because multiplication of any number by 0 will give us always 0, so which is non-negative. We are safe here. So By the way, if we go specific for the case of f of -1 is positive here, in this case the graph looks like 0, there's a -1, it's positive 1 here, and then by the same logic, this small is 0 could be integer or non-integer. But in the case of non-integer smallest value, we always have a trouble, right? We can take the ln l plus 1 containing this non-integer 0. So this does not make sense. And when this smallest 0 is integer, let's say this value is -2, and then its counterpart of the -1, which is -3, f of -3 will be negative here, and for the other integer values, say -5 here, and there will be -4, which has a positive value here, but f of -6 will be negative. So this also does not make sense. So for the case of a positive f of 1, the value of f of -1 should be 0 here. So this is the case. So let me summarize. For the case of f of 1 is 0, then we have a non-positive f of -1. For the case of positive f of 1, we do have another smaller 0 as x equals -1 here. We have two cases here. And my question is, what if the value of f of 1 is negative here? And in this case, the graph looks like this. 1 is here. It does not make sense because we can separate two cases for the biggest 0 here. First case is integer 0 or non-integer biggest 0 here. You can do the same thing, same logic for this case to figure out that the negative value of f of 1, it does not make sense. Okay, so what's left on our hand is either f of 1 is 0 or either f of -1 is 0. Okay, so let's do some calculation for those two cases. For the constant real value a and b, you can put the cubic polynomial whose leading coefficient is 1 as x cubed plus ax squared plus bx. And since this constant term is 0, I just ignore the constant term. Okay, so we need to determine the two coefficients a and b here. So for the case where before doing that, let's compute its derivative. Its derivative will be 3x squared plus 2ax plus b. Okay, and then for the case where f of 1 is 0 and f prime of negative 1/4 is negative 1/4, we have here, first we have 3/16 minus negative minus a/2 plus b here. And for the f of 1 equals 0, we have 1 plus a plus b equals 0. So if you solve this system of equation for the first case, you will have a equals to negative 3/8, b equals to negative 5/8, and this fits for the condition of the derivative of quarter is negative. It will be okay. However, for the second case, where f of negative 1 is 0 and f prime of negative 1/4 is negative 1/4, here you have an equation of negative 1 plus a minus b equals 0. Okay, so the system of equation for this case will be this here, negative 7/16. If you solve this system of equation, you will get 9/8, and for the b 1/8. So this will not give you a negative value of its derivative at the point of x equals a quarter. So this is not the case. We have to choose this case. Okay, let's wrap up this long journey. Here I made some mistakes here. The order zeros are not necessarily be integer, but either the smallest one or the biggest one among the zeros could be integer, and f of 0 should be 0. The reason why I had a difficulty for proceeding the logic of justifying those two values a and b is that there are too many cases which are not simple. You have to interpret the graphs of y equals f of x, and you have to choose each meaning, and by the situation of whether the zero could be integer or non-integer, we we confront two cases on each steps, and you have to figure out what is the right way to go further. And basically, from the start point to the ending finish line, the journey was too long journey. So the exam taker uh, might have felt uh, the same difficulty that I have had when I solve here. Okay, that's it.